Good afternoon, Computer Science 2A. Let's try that again. Good afternoon, Computer Science 2A. That's a little bit better. Are you already tired from the week? Is it already too much? Don't worry, there's only 12 more weeks to go, at least for the first semester. So still a lot of things to go through. Hopefully some of them will be interesting. So this time I remembered to do the attendance, so make sure you do that attendance. We'll start with the actual lecture once that time is up. So Blackboard should be going smoothly, I think. Let's just double check. Yep. So yes, attendance wasn't there yesterday because things weren't working, and this takes time, which I'd rather spend giving a lecture than worrying about admin to make sure that people are actually in class. You're paying for this, you should be here. That's my approach. You are adults, you paying for this, or someone's paying this on your behalf, and you should be here. If you don't want to be here, give them the money back, do whatever you want. Okay, so in terms of what we're going to do today, we're going to have a look at the lecture, which we sort of covered some of the practical applications of, or we started in the tutorial yesterday. We're going to look at the proper theory behind everything now, and then on Friday we'll carry on building up on that problem statement, which we started yesterday, tertiary education registration problem statement that we're going to be working with. So with that, we're going to look at object orientation again. We're going to look at concepts which you've covered already in 1B, but we're just going to take it to another language. So you know about these things, you might not remember them, but you were taught them. We're going to recap them. We're going to look at some similarities, some differences when applying object orientation now with Java compared to something that you already know, C++. And then we'll have a look at some of the new things available, specifically looking at enumerations, and also just recapping on a little bit of class diagrams. So we sort of did that in the practical lecture. We're going to look at an example again now with that YOML class diagram and some source code that goes along with it. And that will assist you in completing your practical 1. So what you'll see is when you're given the practical most of the time on the Tuesday that's going to be due for the following week, at that point in time, you might not have all the tools available to answer that practical, because we're still going to go through some of the content. If you want to do it beforehand, you can go and read the lecture. I'll try and make sure the lectures and the practical lecture are up on the Friday before the following week when they will be discussed in class, and that way you can read through the content beforehand. That way you also, when you come to class, you're not just here to look at me and read the slides while I'm busy trying to lecture. You actually read the slides beforehand, so you know what concept is going to be discussed, because I talk about a lot of things that are not on the slides. So it's no use you trying to read the slides while I'm trying to talk about something else. Also, that allows your brain to process that information and maybe ask questions that are relevant at that point in time. Some of you ask questions still while we're giving the lecture. That's fine as well. But if you give yourself time by reading this content before, you can, your brain has time to process that information, and then it maybe can understand better and ask more complex questions. Because a lot of students come afterwards, maybe the next lecture or the following lecture, ask me about the contents previously because something clicked or something interesting that they thought about and want to know more about it. Okay, so I'll put the timer here, and then we'll go on to the actual lecture. Okay, so I was walking around a bit, that's why I might have been going loud and soft. Okay, so let's have a look at what we're going to discuss. So we're going to look at object orientation, the concepts behind it, and then how we're going to apply it to the Java language. So because we're talking about objects, you have to talk about classes when you talk about objects. So that's the first thing we're going to discuss. When we do programs, we usually do them in order to solve a specific problem, some sort of problem statement. And how we model them is by building up sets of interacting things. Now, before there was object orientation, those things were just functions. You could interact or have things interact by calling different functions at different points in your program. And this would eventually solve the problem. However, functions were very abstract in terms of their definition. They didn't really belong to something. And that's where object orientation tries to put things together. It tries to put related things together that makes sense, that tries to mimic real life content. So you should have seen that when we try to create our student class, that we try to put all things related to the student in that student class. And as we progress further onto things like your modules, your degree, etc., we're going to put relevant things in those classes. And then we also have things that modify that information inside of that class in some way. Now, having things that are stored in that class and having things that modify those things that are stored in the class, they have proper names for them. So what we have is an object state, and an object state is any attributes that it has that makes up the object state, and then the values of that specific object gives you the object you're working with, the instance you're working with, unique identity. Then you have something called object behavior. And object behavior is something that modifies the state in some way. So your object state, we store stuff. Object behavior, we modify the stuff that we already have stored. Other things that are important are the concepts of a class and an object. So these definitions you should know. They were in your exam. One of the exams at least had that definition, or usage of usage of that definition. So a class is a template or a blueprint of an object. You need a class to make an object. And an object is an instance of a class. It's made up of things that were described in a class. So those two go hand in hand. You can't describe one without talking about the other. So this is the general concept of object orientation. It's not towards a specific language. This is general. You could apply this to C++, you could apply this to Java, you could apply this to Python, you could apply this to C#. Any object-oriented language can use these concepts. Other concepts that are going to be important are the principles that underline or underpin object-oriented design. So again, you know of these things. You've seen them before. We're just going to recap them very briefly. We're not going to go into detail about them. We will talk about some of the pieces as they come up. As we go through the tutorial, I'll mention this is where this fits in, this is where this fits in. But you have seen these concepts before. I'm not reteaching you that. I'm just showing it now applied to a different language. So divide and conquer, that's where we have a big thing and we break it up into smaller pieces that we can work on individually. So we take a big problem and we decompose it into sets of interacting objects. In order to make this objects, we obviously need classes. So by that definition, we have classes that we need to create as well. Encapsulation, we're putting attributes and actions of a specific object into a single class. So, for example, having student information and things that manipulate the data of a student, we're going to put that both into a student class, because the data and the the modification of those attributes should belong together. Then we have something called interface. So interface is a word that's used in multiple places. In the context of object-oriented design, interface is the way objects interact with one another. How can they talk to each other? How do objects talk to each other? I'm asking you now, how do objects talk to each other? Messages. What's messages? So the only thing that one object can do with another object is call the methods that are available on that other object. That could be accessors, they could be mutators, they could be method calls that do more complex things, but the way they interact is through those methods. And the only way you can interact with another object's method is if it's available. It's visibility. So an interface defines how we expose the information inside of an object. The state and the behavior, how is that exposed? Is it public? Is it private? Is it protected? Is it packaged? Because we don't have friend visibility, that was in C++. So interface defines how we lay out our classes and make sure that whoever wants to use certain things, they have a way to use it. Information hiding, we spoke about this a little bit when we went through the creation or starting of the creation of the student class. And here we're talking about hiding details from the user. Now, that again, that's another ambiguous word. Depending on the context, that means different things. When we talk about users of classes, users of our code, we're talking about other programmers. When we're talking about people who use a fully built program, those are end users. They're the people who are going to sit with the device and have your program running on that device. And they will type the things that will make your program crash and make you cry. So that's end users. But when we talk about programming and we talk about hiding details from users, it's users as in other programmers. If you are designing software that is going to trade stocks and make money, would you want that algorithm to be publicly available or privately available? If you're the company that developed that algorithm, most likely to make sure that you keep your edge over competitors, you might want to make it privately available. In which case, you're going to hide away the implementation details. You can have people access it. They might need to pay a premium to access that feature. So that's the way you'd hide some information from the rest of the people that might be using it. Then generality, where we're looking at designing classes for a particular kind of task. We are not designing a student class that will work in our system, that will work in a system inside of a chemistry laboratory, something that will work inside of an access control system, something that will work inside of a international student transfer system. We're not going to design one class that will do everything. We're going to design classes to our specific task. There might be some similarities across the different systems, but we want to make sure it's for our specific application. The same way that you might have a car class in a system. And that car class, depending on the system you're working with, might just be storing information about how many passengers it can store, and that's it. But if you're designing another system where it's a self-driving car, that car class and its extra things like sensors and stuff will be more detailed. It depends on the task you are doing, how complex or how simple your classes are going to be. So when you design stuff, you design it for your application. You can't design it to be as general as possible. You can try, but you're going to waste your time doing things that might not be needed for your specific application. Extensibility, this is something that you need to think about all the time, especially when you go out into the real world and you need to design software. How long is that software expected to be around? Who is going to be using that in the future? So extensibility thinks about not just now, not just thinking about the current time and space, but talking about the future as well. When you're writing software, you want to make sure that you think about the future. Is this going to stay like this all the time, or will something change in the future? If we look back at 2020, January was very nice. And then a few months later, the world was in chaos. And a lot of things changed. So you have to think about what's going to happen in the future. Maybe COVID goes away one day and we're back to normal. But that doesn't mean another COVID is waiting a few years later. And we might be stuck back in remote time. So you have to think about what is going to happen when you want to try and extend the system to different situations and also different applications, different situations at whichever workplace it's working. All of these different things, you need to think about it. Now, when you're talking about these type of things, we'll see extensibility when we get to design patterns. We'll talk about that a lot in design patterns, because design patterns are basically best practices, not to say the only thing you should do, but best practices for certain tasks. They say don't reinvent the wheel. That's basically what we're trying to do when we talk about design patterns. There is a certain way to do these things because it works really well. That doesn't mean it's the answer for everything, but it gives you another tool in your toolbox. And then abstraction, focus on the important and relevant parts of an object. So that I kind of touched on that when we were looking at the student class, and I asked you about hair color. For our specific task, hair color of a student is not important. Whereas if you're designing, like I said, a hair salon, maybe the color of your client's hair is very important, especially when you need to do different treatments. And depending on the hair color, certain colors you can't do because of the natural hair color. So you have to think about what is relevant to your current situation, what is relevant to your current problem. So again, these are general principles. They're not specific to any language. Language also have features to enable them to work. So for example, information hiding, you have visibility modifiers in most languages. C++, you had visibility modifiers, public, private, protected frame. Java, you have visibility modifiers, public, private, protected package. Python doesn't really have visibility modifiers, but they have syntax that dictates certain things are essentially public or private. So every language that is object-oriented in its design can implement these things correctly. How do you implement correctly? We showed you that a little bit of that in 1B, and I'm going to show you again now in 2A. So let's look now at the Java situation, because the whole thing we're trying to do is teach you object orientation in Java. So with Java, you have attributes, and those are going to be known as instance variables because they belong to a specific instance. So if you think yourself as an instance of that student class, what things are unique to you? So if you look back at that, what we started with the student class, we had things like student number. That's unique to you. You have other attributes like first name, middle name, last name. Might not be necessarily unique, but that combination in conjunction with your student number, that is unique to you. So those belong to an instance. It belongs to that thing only. Then we have actions, which are instance methods. So the methods that are available on that specific instance that can either access the state or modify the state. access the instance variables or modify the instance variables. So that belongs to an instance. When we talk about static, static belongs to the class. It belongs to every one of the instances inside of that specific class. So any object that is made from the class, it belongs to all of them. So say, for example, you're looking at yourself as a human being. At an exact point in time, how many people are there on Earth? Plus or minus 7 billion. Is it 8 now? Okay, 8 billion. And if you look at the person next to you, how many are there? Same amount, plus or minus 8 billion. So between the different instances, the number doesn't change because it belongs to the whole of the human race, the number of people in the world. It belongs to the class as a whole. So static belongs to a class. It is not unique to each instance. Instance variables are unique to each instance. So that's what the static modifier does. It belongs to the class. It doesn't belong to an instance. So constructors in member access, we looked at some of the details here already. So by default, if you don't specify any constructor, Java gives you a default no arguments constructor. Constructor is always the same name as the class itself. It doesn't have a return type because it returns an instance of the class, just like you have in C++. But by default, it gives you the empty arguments constructor, no arguments constructor. So you can create an instance without assigning anything. Now, one thing which happens is as soon as you create a constructor, that is the only constructor that's available. The default one falls away. So bear that in mind, that when you define your own constructor, there is no more a default constructor. It's the one you define. So be very careful of that, and we'll have a look at that when you get back to the tutorial tomorrow. When you want to access something inside of an instance, then what we'll do is we'll call the member access operator, and that's your dot operator. So you go dot, and then something of that belongs to that instance. If you want to get something from a class, instead of putting instance there, so in that second line of code, you can see there, it says instance.getVariable. If you're accessing something that is static, you put the class name dot and the thing you want to access. So if it's static, you can access it by class name instead of whatever instance name you have. When we're working with reference types, there is a keyword for reference types that point to nothing, and that keyword is called null. Now, there's a lot of discussion about this keyword. Some people say it shouldn't exist because it leads to problems. Some people say it should exist because it avoids certain problems. Nonetheless, Java has this keyword called null. Any reference type that doesn't have a value is assigned the value null. It means that that reference points to no memory. That's what it basically boils down to. It points to no memory. Because remember, at the end of the day, a reference is a pointer, and pointer needs to point somewhere in memory. So null, special keyword that says does not point anywhere. The reason why we need to speak about this is if you have a variable that is a reference type, so an instance of a class, and you try and access something inside of the class when it's null, then you're going to run into something called the null pointer exception. You try to look at memory that doesn't exist and try to access something that isn't there. Null pointer exception. So if you have instance variables in your class, so for example, we have student number, first name, etc. Those are given default values. Instance variables are given default values. Default values for strings is an empty string. Default value for numbers are 0. Default values for Boolean is false. Default value for reference types is null. That only works for instance variables. As soon as you have temporary variables, so variables inside of a method, then there is no default specified. They are uninitialized. It's the same way as if you have an pointer, array pointer inside of C++, and you don't allocate memory for it, and you try and use it, it's not initialized. It doesn't have a value. It might give you some results, it might crash your program, but it's uninitialized. If you have an instance of an object, you create, for example, a student, and you go out of scope. Maybe you have it in a for loop exits, maybe you have it in a method called completes. Any reference type, after it's being used and is no longer needed anywhere else, the garbage collector will mark it for collection. Doesn't collect it at the same time. Remember, Java garbage collection comes when it wants to, so it just marks it up for collection, and then when the garbage collector is ready, it will come and free up that memory. Modifiers, we've already spoken about these quite a bit. Just to recap, visibility modifiers, public, private, protected. Public, visible to all, so any class, anywhere. Private, only accessed within the class itself. Protected, the class and subclasses. So classes and subclasses, we'll talk about that when we get to advanced object orientation. You know about having classes and subclasses already. We haven't looked at it in Java yet, but that is available. And if you don't specify any visibility modifier, it's package visibility. So anything in the same package. And you'll see a couple of slides later, we'll talk about packages. So enumerations? Okay, so the question is, for enumerations, are they public by default or is it something else? If you don't specify anything, it's package. That doesn't matter if it's an enumeration, doesn't matter if it's a class, doesn't matter if it's an inner class, doesn't matter if it's an outer class, doesn't matter if it's a record. Those are all the things we'll look at eventually, but it doesn't matter. If you don't specify any visibility modifier, by default, it's package. We'll talk about enumerations there, way at the end there. Other modifiers, so not visibility modifiers, these are other modifiers. Static, we already talked about that. Just to recap again, belongs to the class, doesn't belong to an instance, belongs to the class. We can have static methods, and we can have static variables. And then another interesting one is the final. Now, final values, so instance members, final instance members, attributes, they are values which you cannot change. So you can think of them as read-only or constant values. But you can also have something called final methods. And final methods, that's something that we'll discuss when we get to advanced object orientation. So it's there. Keep it at the back of your mind. And when we get to advanced OO, we'll talk about what is final methods. Revisiting a topic we discussed before, scope of a variable. Now we need to talk about scope of a variable inside of a specific class. If we look at instance variables are available in a class anywhere inside of a class, whether it is inside of a method, whether it is inside of for loops inside of that method, anywhere in that class, it's available to use. If we have variables that depend on each other, they have to be declared in a top-down fashion. So for example, if we have the area of a circle, and that depends on the value of radius, we have to have radius declared before the radius of, area of that circle. So that's something that you need to keep in mind. If you have variables that depend on each other, You have to have the one without dependencies first and the one with dependencies declared afterwards. Now, good coding practice, you should put all the variables of the class, whether they're private, whether they're public, whatever they are, at the beginning of that specific class. Now, for C++, things were a bit different because you had your public section and your private section. Usually, you had your private section. I think that was a convention that you were taught. Correct me if I'm wrong. Is that what you were taught? Private section second, and then because all your instance variables are using information hiding, they're usually in the private section, so they're always at the bottom of your definition of your specific class. Java says maybe that's not a good idea because you have to scroll past all the other things and then see your instance variables. So Java says put the variables at the start and then constructors and then methods. This is a convention, it's not hard fact. So it's a good idea to do so that when other people read the code, their expectation matches what you're actually doing. You can't put things in between each other. You could have a constructor, one variable, method, another variable, method, but then when people go and read your class, it doesn't make sense. It looks weird. So the convention is put your variables first, static and then instance, then put your constructor and then any other methods, instance methods that come in afterwards. Then the last point there, we're talking about overshadowing fields. So overshadowing is something that I need to show you to make sense. But what that basically means is if we have a local variable, the same name as an instance variable, the local variable takes precedence. It means when we call that local variable, whatever value it is, the local version will take preference over the instance variable. So when we get to the tutorial tomorrow, I'll show you a case of that actually happening. This keyword you have seen before as well in C++. And this keyword is used to access the current instance. So when you want to access things inside the current instance, you can use this keyword. So that problem of overshadowing can be overcome by using this keyword, and we'll see that in the tutorial tomorrow. But what it can also do is it can call constructors of the class, the other constructors. So let's say we have 3 or 4 constructors. We can have the first one called the second constructor. We can have the fourth one called the third constructor. So we can chain constructors together. Might be a reason to do that, depending on the number of arguments we provide. So that's the way we can work constructors together. In C++, you could have the notation where you could initialize things using the colon member and then value syntax. We don't have that available in Java. We have to have constructors and explicitly initialize things in the body of a constructor. Now I come to the fun part, packages. So packages are a way to group related classes together. You did the same thing in C++ with namespaces. You had a specific namespace. And the reason why you have namespaces, the reason why you have packages is so that you group your things together and there is no ambiguity with regards to what thing are you referring to. As I mentioned previously, you might have a car class that is just used to store some information about how many passengers are available, whereas another car class might store information about how to navigate a network. And those two car classes might have different things, but at the end of the day, the name of the class is car. So how can I tell which one is which? Put them into a different namespace, put them into a different package. So packages are just a way to group things, and you have a name for that package, and that will indicate where does that specific thing belong. So question is, generally, just like in general, how is Java better than C++? Good question. I don't know. I don't know. I don't think it's better. The same way I don't think Python is better than C++. Same way C++ is not better than Python. It's like saying which one is better to twist in a screwdriver or a hammer. Both will work. One works better than the other. But then if you have a nail, other one works better than the other one. So the whole point of what we try and teach you here at the Academy of Computer Science and Software Engineering is not to say this language is better than this language. This tool is better than this tool. The whole point of what we're trying to teach you is learn the tools and choose the right one. If you want speed, C++. If you want to keep your sanity, Java. Because you don't have to worry about pointers. So it depends. There is no this is better than this, absolutely. There might be certain things that work better in Java, and there might be certain things that work better in C++, but there is no absolutes. It's like comparing a two-door cheap car and a very expensive sports car. Which one's better? Which one? Well, if I have no money, two-door is cheaper to buy than the sports car. So it all depends on circumstance. That answer, it depends, that should be my catchphrase, because anyone asks me a question about what to do in life, what to do with software, what tools to use, my first thing I say, the first thing I always say, it depends. And that is applicable to anything in life. It depends. The more experience you have, the better judgments you can make about what to do. At this point in time, you know C++ very well. At least I hope so. So when someone asks you to do something, that might be the first thing you go and try, because that's what you know. But as you go through the course, as you go through second semester, you'll know more Java. And Java you might think Java is the best thing ever, and then completely forget about C++. And that's very much possible. But what I want you to realize is it's not going to be one or the other. If you look at other universities, I'm not going to name any names, they only teach you one language, and this whole degree is just one language. So when they leave, what do they know? One language. With us, you're going to learn different languages. Just looking at computer science alone, you learn C++, you learn Java, and you learn assembly. If you're doing informatics, then you also learn VB, you learn SQL, although that's not really a programming language per se. Then you also learn in your third year, depending on what you do for your third year project, you can learn any number of languages, C#, JavaScript stuff, it all depends. So we try and teach you to be an IT person, not just a single one-trick pony developer. Someone had a question here in front? Yeah. Okay, so I'll get to the question just now. Okay, so going back to our topic of packages, when we look at the names of our different packages, what I want you to try and wrap your head around is that packages are usually belonging to a specific company. And there is a certain way companies are being known. Now, when you type something into a website name, you usually type in the name of the company dot something at the end. And it's sort of reverse order of what is shown here. And a lot of people, even including the person who invented the internet, says it should have been in this order, where you go from most general to most specific. So if you look at the order there, you'll see the package name there is ZA. So ZA is the two-letter code for South Africa. AC, academic. UJ, ACSC, Academy for Computer Science and Software Engineering. and then CSC02A, the module. So you're going from least specific to most specific. And then we can still go further. There will be extra things which we define afterwards called sub-packages that belong in that specific thing. So usually it's the URL of the company in reverse order. So you can see there, sort of, if you put that in reverse order, you can sort of see xc.uj.ac.za. Unfortunately, we weren't called axc all the time when UJ started. That's why we don't have axc as the name of Eve. Eve was the name that was chosen. So that's how packages are usually named. And what you'll see is when you use third-party libraries, when you use other people's Java code in your code, you will have to call packages and you'll see the names correspond to that syntax. Now, what's interesting about how the syntax is laid out is that each dot that's specified in the package name corresponds to a folder where you will find other things inside of there. So you'll see that if we have something called class name, could be student or could be whatever, that class file, the .java file, will be found in the ZA folder that has an AC folder, that has a UJ folder, that has an AC SSE folder, that has a CSC02A folder, and in that CSC02A folder, that's where you'll find your .java file. Now, the way these packages are laid out and the way you're going to write code to have different classes in different packages, that is not going to translate directly into making a giant batch file that will compile everything. If you remember back to yesterday's tutorial, did we have to specify student anywhere inside of our batch file? When we compiled main, what happened? The compiler said, okay, to compile main, I need to find student. You told me where the source code is, it knows where to look for student. So all that's going to happen with our batch file is we're going to compile main. Main will tell the compiler where the other classes are by specifying import something. And import is the same way you say using namespace. So import, and then you'll have that package name dot whatever class you need. So that's how we're going to work with packages and try and get code to be in separate places that make sense, but also available inside of our program at the end of the day. Basically, if you look at what is the equivalent between C++ and Java, C++ has namespaces, Java has packages. Basically the same thing. Obviously, the compilers are different, the languages are different, but conceptually they are the same. There is no circular referencing that can happen, so you don't have to worry about that. With C++, you have to worry about header files included multiple times and header files that include other header files. We don't have a header files in Java. We don't have to worry about circular references. Immutable objects. So this is an interesting topic which we'll get back to sometime in the future. But immutable objects are basically something that when we create them, we assign them values, and throughout their lifetime, they cannot change. So we'll see examples of this. This is a very broad definition, but we're not going to look at specific examples right now because it won't make sense to. So something that we'll look at in the near future are strings. And by default in the Java language, strings are immutable. So how does that work? Because I can change strings, I can concatenate strings inside the language, but they are immutable. So we'll talk about what that means when we get there. But for a class to be immutable, there's a couple of things that need to happen. All instance variables need to be private. There's no access to any instance variables. No mutator methods because it's immutable. You can't change it, so there's no mutator methods. And the last one is a bit tricky. No accessor methods return a reference to a mutable data type. What that means is when you return a reference, that reference also needs to be immutable. So that's one tricky thing that you need to think about with immutable objects. So again, don't worry too much about immutable objects for now. We'll get back to them very soon. Okay, so I'm going to go quickly through the last few slides. UML class diagrams, we went through the documentation lecture, practical lecture. We've looked at some abstract example here. We can see a concrete example. So there's your circle class, there's your radius inside of the attribute section, and then all your methods available inside of the operation section. You can see the data types, etc. correspond, and that will give you your class there. Then the last thing we need to look about is enumerations. So enumerations are special types of classes. They look like classes, they smell like classes, but they act like something else. They work with the keyword enum instead of class, and they define instances that can only be those values. So when we create an instance of, for example, here, E workday, and you notice there's an E in front, that's a convention, E for enums. So weekdays. So those are the only values allowed for any variable of that type. We cannot assign, for example, 10 to this reference type, or even a student class. We cannot assign that. It can only be one of those values. Now, this is different to something like C++ enums. C++ enums are just numbers. 0, 1, 2. You could put a number like 99 in the middle there and have 102 a bit later, but at the end of the day, they were just numbers, and that's all. With Java enums, they're full-on classes, so you can store data along with an instance. So here, for example, we have something called message priority. So it's an enum for message priority. And there you can see we can store additional attributes with the priority. So message priority, we have a low, normal, and high, but we store additional information. For example, color. That might be used in an interface. So if you have an email client or something and a message comes in, if it's high priority, we can color it red. If it's a low priority, we can color it blue. Something along those lines. It also has some other values, priority, that can be used in some other way. Maybe a priority queue, something you'll learn about in Computer Science 3A. And because this is a class, it also needs a constructor to do that, but you'll notice here, it's a private constructor, because you cannot create more instances. The only values that are allowed for message priority is low, normal, and high, nothing else. So that gives you a lot of flexibility in terms of what you can store with the classes, but forces whoever wants to use the class. And remember, when I talk about users, in this sense, I'm not saying end users, I'm saying other programmers. It forces those programmers to make sure they're only allowed to use those 3 instances and nothing else. All right, so that's where I'm going to end today's lecture. We're going to cover some of these topics again in tomorrow's tutorial, and obviously the tutorials that come afterwards. If you have any questions, I'll be here in the front. Otherwise, I'll see you tomorrow.